Next up on our list of reasons why equality can be hard is that some data types are inherently approximate. In .NET, you'll encounter this problem with the floating point types, float, double, or decimal, or of course with any type that contains a floating point type as a member field. Here are two numbers, 6.0 and 6.00, lots of zeros, 1. Are they equal? Well, it looks pretty obvious that they are not equal. They differ in the final digit. And I have a line to check that. Let's run the code. Uh-oh, it displays true. This program has come out saying that they are equal, which is completely counter to what our eyes are telling us when we look at the numbers. And you can probably guess what the problem is. Computers can only store numbers to a certain level of accuracy, and the float type just cannot store enough significant digits to distinguish these two particular numbers. And it can work the other way round too. Here's a simple calculation. We're adding 5.05 to 0.95. It looks very obvious that when you add those two numbers, you'll get the answer 6. So let's go back to Visual Studio. I have another program now which does exactly this sum using C#'s float type. It displays the answer and checks whether it equals 6. And if I run that, look at that. It's told us that the answer does not equal 6. The reason is that rounding errors have happened in the floating point arithmetic, resulting in the answer storing a number that is very close to 6, so close that the string representation in console.writeline even displays it simply as 6, but it's still not quite equal to 6. Those rounding errors in floating point arithmetic have resulted in the program giving the opposite answer to what any common sense reasoning would tell you. Now this is an inherent difficulty with floating point numbers. Rounding errors mean that testing for equality often gives the wrong result, and .NET has no solution for this. The recommendation is that you don't try to compare floating point numbers for equality, because the results might not be what you predict. This only applies to equality, by the way. This problem doesn't normally affect less than or greater than comparisons. In most cases, there are no problems with comparing floating point numbers to see whether one is greater than or less than another. It's equality that gives the problem.